Institution Mobile, quality e-learning experience on the go.
An acid is a substance which forms hydrogen ion as the only positive ion when dissolved in water. You can also say it produces hydronium ion instead of hydrogen ion, whichever is correct. Acids examples are, we have hydrochloric acid, we have the nitric acid, we have the sulfuric acid. These are old names. So we also hydrochloric acid, yeah, still the name. Nitric acid is also known as the triocto nitrate 5 acid. The sulfuric acid is also known as the tetraisosulfate 6 acids. We have bases. Bases are oxides. Bases and they produce hydroxyl ion as their only negative ion in when they are dissolved in water. Now we have sodium hydroxide, we have calcium hydroxide, and many of them like that. Acids basically dissociate. When they dissociate, the strength of the acid is dependent on how strong the electrolyte is. An acid with strong electrolytes, that make very good electrolytes, is known as a strong acid, while those ones which are relatively weaker level of electrolytes are required, regarded as weak acids. And this also is also related to the base. Bases with strong, which make strong electrolytes, are known as the strong bases, while those ones that have weaker electrolytes are known as the weaker bases. Yeah, we're talking about the basicity of an acid. What is the basicity of an acid? Basicity of an acid simply talks about the amount, the number of hydrogen ion being produced when the acid is dissolved in water. Now, if we consider hydrochloric acid as seen in the diagram, it has just one acid and one hydrogen ion. So it's said to be monobasic, while tetraisosulfate 6 acid is basic, and tetraisophosphate 5 acid is tribasic rather. Of course, acidity of a base. Acidity of a base also talks about the number of hydroxyl ion that can be found in the base when the base is dissolved in water. Sodium hydroxide is monobasic, while calcium hydroxide is dibasic. Now we have some acids. The acids are displayed: the hydrochloric acid, bromic acid, and all others. All the names here are the old names that we used to call the acids, but now we have the IUPAC name. The IUPAC name it's very important that you get to understand the IUPAC name. It also gives more information about the acids, not just about knowing what they are, what they look like. It gives information about their oxidation states as well. This also shows the weaker acids. The first ones are strong acids, and this talks about some of the weak acids. Naming about acids. Acids are they are either binary acids, or as we are seeing hydrochloric acid, they can be ternary acids, polyatomic. Binary means that they just have one two different elements coming together to form the acid, and ternary means they have more than, that is, many atoms coming together to form the acid. Now this also depends on what kind of thing it contains. That's what actually helps us in naming our acids. Properties of a base. Yeah, a base. Bases generally, they have pH that is higher than 7, and they are bitter in taste. Acids are sour in taste, bases are bitter in taste. Bases they neutralize acids. Of course, acids also neutralize bases, and bases turns litmus paper blue, while acids turn litmus red. Bases also are actually named in a specific manner. Of course, all of them do, depending on how many in number of them. Depends on the oxidation states of the ion of the metal which is used to form the base. Now, these are the physical properties of acids and base. I've mentioned some of them earlier. just like it, just look through them and get them memorized. It's very important. Some of these questions could actually come out in your examinations. Chemical properties of an acid. With metals, acids react and produce salt and hydrogen. The hydrogen comes out in an effervescence, and the reason is because the metal displaces the hydrogen because of its higher electropositivity. Now, also, acids react with bases to give us salt and water. Yeah, bases also already contain a certain level of oxygen in them. Not only bases do they react with, but some acids also react with oxides of metals, and produces salt and water. Also, acids react with trioxocarbonates, that's either calcium trioxocarbonate, sodium trioxocarbonate, magnesium trioxocarbonate, whichever metal trioxocarbonates you have. When they react with them, they produce salt, water, and carbon dioxide. The carbon dioxide comes out with an effervescence. Neutralization process. Neutralization process is simply the chemical reaction between acids and base, producing salt and water. That is what neutralization is about. Now, usually it's a double displacement reaction, and I have some of those reactions listed in this slide. You can just take a look at them and try to observe. The second of the this thing is not balanced. I purposely left it there that way so you can actually take our time, try to balance it out. Let's see how well you have mastered your balancing of chemical equations. And formation of hydroxyl ion. Yeah, hydronium ion. Hydronium ion is formed when an acid dissolves in water. Of course, when an acid dissolves in water, it gives us this hydrogen ion, and when it gives us this hydrogen ion, the hydrogen unites with the water and forms the hydronium ion. Now, it's this hydronium ion that actually characterizes our acids, and it is responsible for its activity, its reactivity. Uses of acids. Of course, there are a lot of uses that acids do have. Acids are used in car batteries. If you're in the human stomach, the acidity of the human stomach is about, the pH of the human stomach is about 1.4 to 3.0, which indicates very, very strong acids. It's also used in the manufacture of fertilizers, soap making, saponification, and of course, it's very useful in medicine as well as in some other fields of work. Acids are sour in taste, so anything you put in your mouth that has a sour taste, there's a very high chance that it is acidic in nature. Chemical properties of bases. Of course, firstly is neutralization. Bases go through neutralization, and yes, they precipitate. When you dissolve metals in them, they precipitate because the metals react and they produce some form of the metals displace each other in them. Type of oxides. We have several types of oxides, and four major types that are very, very important. The first one I'll talk about is the basic oxides. Basic oxides are oxides of metals, and usually metals which have a high oxidation state. These oxides, these metals do interact with the oxygen, and when they are dissolved in water, they usually form bases. These oxides are usually, they all are actually, they react with litmus, and they convert litmus from red to blue. Acidic oxides. Acidic oxides are oxides of non-metals, and they are acidic in nature, which means they convert blue litmus to red, and of course They can also take part in chemical reactions. Yeah, amphoteric oxides. Amphoteric oxides are metallic oxides, but selective metallic oxides. These metallic oxides react with both acids and bases, and they produce salts and water in both cases. So they are actually in between. They don't make strong acids, they don't make strong bases. They are actually in between acids and bases. And we have the neutral oxides. The neutral oxides do not react either with acids or bases. They are just there. Examples of all these kinds of oxides have been presented in slides. Let's talk about the pH. The pH is a measure of the alkalinity or the acidity of a solution. It is defined as the negative log of the hydrogen ion concentration. Now, the method of calculation, you just calculate the level of the concentration of the hydrogen ion, and you calculate the log, the antilog rather, the antilog of it. That gives us the pH. Now, if our pH is less than 7, it shows acidity, while when it is greater than 7, it shows alkalinity. 7 is the neutral point, and you should take note of that. Molarity of a substance. Molarity talks about concentration of the acids and bases engaging in titration. Now, the concentration has been defined, and these formulas displayed on the slide are very, very, very essential in our calculations of molarity and amount of a substance. Amount of a substance is also known as the mole. So, salt. What is a salt? A salt is a compound that is formed when the oxidized hydrogen of an acid is replaced with another metal or ammonium ions. Of course, ammonium is the only non-metal that actually forms salts. We have the ammonium salt. Well, we have different types of salts. We have the normal salts. Table salt is a normal salt. These salts are neutral to litmus, and they are just normal salts, as the name implies. We have the acidic salts. Acidic salts are acidic in nature.
Fusion Mobile, quality e-learning experience on the go.